Hi everyone, my name is Pavindran son of Ponusami and my metric ID is TN23038. So today I'm going to explain about the topic or chapter called transformer. So transformer are electrical devices used to change the voltage level of an alternating current AC electrical signal while keeping the frequency constant. They consist of two coils of wire called the primary coil and the secondary coil, which are wrapped around a common iron core. So basically, there are two types of transformer. First one, step-up transformer, and the second one is step-down transformer. So in the end of this discussion or explanation, we would be able to understand the difference between step-up and step-down transformer. Furthermore, I will explain about the step-up transformer and step-down transformer. There are two types of transformer. First one, step-up transformer, and the second one is step-down transformer. So in the end of this discussion or explanation, we would be able to understand the difference between step-up and step-down transformer. Furthermore, I will explain about the step-up transformer and step-down transformer. So firstly, let me explain about the step-up transformer. Voltage extend adventure. Climb the coils to reach new voltage heights. Step-up transformer increase the voltage level from primary winding to the secondary winding. This means that the output voltage across the secondary coil is greater than the input voltage across the primary coil. So the number turns double, where each lifts voltage to greater altitudes. Where the current flow in the flow by the magnetic field, electromagnetic field, it will loop and lifts to voltage to the greater altitudes. The number of turns in the secondary coil is greater than the number of turns in the primary coil. The ratio of turns determines the voltage ratio between the primary and secondary coils. Electromagnetic elevator extend from low voltage to the heights of power transmission. Step-up transformers are usually used in power transmission system to increase the voltage of electricity generated at power plants before it is transmitted over long distance to power lines. Higher voltages are preferred for long distance transmission because they result in lower current levels and reducing energy losses due to resistance in the transmission lines. Second type of transformer called step-down transformer. Firstly, voltage vortex. Spiral down the voltage waterfall from primary to secondary, meaning the current supply from the primary coil or primary winding is higher than the current released from the secondary winding or secondary winding. Due to, for an example, the current supply from the power plant is higher than the current we use it in the houses areas. So it uses the step down transformer to convert it from higher to lower from the power plant to our housing areas or business areas. So don't worry, we will look further in the next slide. Secondly, coils count canyon, where turns decide the voltage destiny. The number of turns in the secondary coil is less than the number of turns in the primary coil, resulting in a lower voltage output. Step-down transformers are commonly used in various electronic devices and appliances to reduce the voltage from the power outlet to a level suitable for use by the device. For example, the transformers in phone chargers and laptops and power adapters step down voltage from the standard household voltage to the low voltage required by the device. So don't worry, we will look further in this next slide. In this slide, I want to explain about the uh, current supply from the power plant uh, and the current release from the uh, housing areas. So, in a power plant, electricity is generated at a relatively low voltage, typically in the range of 1000 volts. However, for efficient transmission over long distance, the voltage needs to be increased. This is where step-up transformers come into play. The generated electricity is fed into a step-up transformer, which increases the voltage to much higher level, often in the hundreds of thousands, or even millions of volts. The purpose of step-up transformer in a power plant is to facilitate the long-distance transmission of electricity. So after that, the step-down transformer, once the electricity reaches the distribution substation near populated areas, it needs to be stepped down the lower voltage suitable for distribution to homes, business, and other consumers. This is where step-down transformers are employed. The primary purpose of step-down transformer at distribution substations is to reduce the voltage to levels suitable for safe and efficient distribution to consumers. Common distribution voltage vary depending on the region and local standards, but typically range from a few thousand volts to a few hundred volts. In summary, step-up transformers are used in power plants to increase voltage levels for efficient long-distance transmission, while step-down transformers are employed at distribution substations to reduce voltage levels for safe and effective distribution to consumers. Both types of transformers are essential components of the electrical grid, enabling the reliable delivery of electricity from power plants to end users. That's all from me. Thank you.